Traffic in city skylines usually gets judged one way. The number drops, the road turns red, and it feels like something has failed. But that is not always what is happening. Sometimes the system is broken, and sometimes the simulation is just absorbing a wave of new trips. At the end of Ridgewater EP005, I made a realistic planning decision. Industry moved farther away from the interstate and into a cleaner production edge. That made sense for the series. But this is Enter the Sandbox. So today, the question is simple. Did that realistic layout only look right, or can it actually survive the game mechanics? We're going to stress it two ways. First with a massive residential shock, then with a commercial demand pushed even higher along Main Street. No new highway access, no turn lane fix, no traffic light timing, just the road network Ridgewater currently has. The question is not whether traffic reacts. It does. The question is whether the layout fails. Okay, welcome back to Enter the Sandbox, where we do our deep dives and test game mechanics. So, episode 5 moved our industrial park basically as far away from our interstate connection as we possibly could have. Which, in normal realm of thinking with city skylines, that is kind of the anti-opposite of what you want to do. Typically, you want to put your industrial as close as possible to your main intersection, your main interstate, and you want it to be able to get off the interstate and get on the interstate as close as possible. So we kind of broke that, and broke it more, not intentionally, but definitely for realism. And, because the way our town is being laid out in Ridgewater, it didn't make sense for industrial to be over here. But that means the freight has to travel through our collector all the way to a dedicated entrance completely on the other side of town. And then it has to then travel and deliver to our main street over here, or go ahead and ship out and leave via the interstate. And then we have our farm, which also does the same process. It either ships out or brings it into our bakery, which we put in our industrial, and just runs its own supply chain loop. Well, when we put it over here, initially kind of seemed like we take a hit on our traffic. So far, we're not seeing that. We have 88% right now. 87, flexing a little bit, which is normal. And even our heat map here it's really quite cool. This is our main industrial. This is our main industrial turn off. Trucks are flowing in and out with relative ease. Here is our county public works, which is getting, a lot of trash vehicles spawn, to maintain that. So there's still a lot of movement. And then on top of that, at the very entry point, we added more farm processing. Flour, which is going to have to go to the industrial park. Crops, which, we have some storage, keeping it close by on both facilities, and even our small animal pasture is still nearby those, but it still means that from our fields, it still has to be shipped over. So on our last episode of Enter the Sandbox, we took the deep dive into our farm supply chains and layouts and road optimizations, and that seems to be serving us very well. We're seeing pretty minimalistic traffic here. Now, I do think that the Mud Road custom assets that I'm using is kind of hiding the heat map from us, but we're still seeing our exit points and they're still staying relatively cool. The first mechanical question is route commitment. In city skylines, vehicles do not wait for traffic to build and then behave like live GPS drivers looking for a better road. When a vehicle starts its trip, the simulation calculates a route through the connected road network. That route is shaped by road layout, speed limits, restrictions, intersections, and overall path costs of the trip. That matters here because Episode 5 moved the industry farther from direct interstate access. Visually, that made the industrial edge cleaner and more believable. Mechanically, it changed the route every freight truck now has to complete. Instead of leaving industry and immediately reaching the highway, freight has to move through the dedicated industrial road, into the collector corridor, and then back toward highway access. So the first test is not whether the placement looks realistic, it is whether that realistic placement still survives the pathfinding underneath it. So I think what we really need to do to test this theory is slam a bunch of residential on it and really get this population spiked to where we have a lot more commuting, a lot more vehicle spawn, and a lot more pathfinding to see if we can keep this long travel to the new industrial park clean, fluid, and functional. So let's go ahead and take advantage of this section, this undeveloped section, and just kind of just throw down an unrealistic amount of residential. And we're going to go ahead and create kind of a cardinal sin at the same time. Let's go ahead and spike off Main Street and create a four-way intersection here to kind of stress test it a little further. And so let's do a little catch up here at the end toward the end of the episode, or episode 5, we kind of moved our budget around to help accommodate for our current population size because we're definitely oversupplied. But let's just go ahead and kick that up to max. Let's go ahead and let's see what we have. Let's just go ahead and put another 1 mil down. Kind of bulk up on power a little bit. And let's add some grids. And now we can, we don't have high density residential in, so we'll just jump in to find it. Grab our residential, grab some bigger buildings. This looks like a plenty good apartment building, and let's just place them. Now we should start seeing some legitimate spikes. So we have 1,200 instantly trying to come in. And so there's a few things that we're going to see right off the bat. And one being the initial shockwave of this much residential coming in all at once. So we can expect that traffic to drop pretty dramatically when these cars start to spawn. Because all these buildings throughout that spawn, so we're going to have a mass entry. So let's speed the simulation and kind of watch that come in, and then we can reevaluate where our traffic is sitting once that's calmed down. Now we seem to have balanced down a little bit. We're only pushing a plus 65, but we've put on a massive amount. We went from 2,300 to over 7,400, pushing 7,500 residents. Now, we are sitting at 86%. So we have a little bit of a hot spot right here at the four-way, which is definitely expected. The second mechanical layer is node spacing and lane choice. City Skylines traffic does not behave like human drivers reading the road in real time. Vehicles are following calculated paths, and their lane behavior is heavily shaped by junctions, lane arrows, and the amount of road segment available before the next node. When nodes are packed too closely together, vehicles may commit to a lane too early. That can create the classic single-lane stack, where a multi-lane road technically has capacity, but most of the traffic is trapped in one lane before the turn. That is why the spacing around the collector matters. The intersection can still heat up, traffic can still react, the road can still turn red, but cleaner spacing gives vehicles more room to sort before they hit the pressure point. And because I'm not using lane connectors, signal timing, or a turn lane fix to rescue this test, the layout itself has to do that work. Now, we are definitely seeing quite a pickup in our heat map here, but this seems to be what I would consider a influx in crash, and we have a lot more usage kicking out, and it looks like we're really starting to max that a little bit. Yeah, we're starting to really push our services about as far as they can be pushed, and which is a good thing. This is what we were trying to do. I mean, we're not really trying to identify utility public works lapses because we're sitting at 7,500 residents, and I don't know that we necessarily set out to be that covered, but we can definitely kind of kick our budgets a little higher and ease that a little bit for now. But what we're interested in is, now that we have over 7,500 residents, how is our freight moving? And by the looks of it, so we have, I'm assuming I'm still selected here on trash, and that's where we're moving, but we have some private citizens coming in and out. We have public transport coming in freely. We have, same here. Now we're hitting a not enough special goods, but that's not really a traffic issue. We're still a little short on flour, but we are still seeing normal flow in and out, and we're still seeing normal flow out of our farm, and they're supplying into the commercial zone a little bit. So we're still seeing standard movement we want to see. Now here's the postal sorting, and it's still coming and going off and on the interstate. And same here, leaving. And same here. And it's actually taken a few different routes, but all still running normally. And we're still sitting at 87%, 86, 87. But what we're not seeing is not enough goods. And that is what we're really looking for, outside of traffic jams and intersection chaos and everything you'd expect out of traffic. So let's kind of keep the town running a little bit here. And so that didn't stress us out. So we have a massive commercial demand. So let's add as a secondary test, let's add some heavy high density commercial, because high density commercial really pushes the game mechanics to constantly request buys from industrial. So that should kind of peak up our traffic usage a bit. I don't know how much we can handle of this high density, so we'll throw in some normal density commercial on the rest of this Main Street extension. Okay, so that should hopefully take us down. Let's speed up again and let that settle down and start requesting goods and start seeing what it does to our traffic with a monster Main Street extension. The final check is economic verification. A good traffic percentage by itself does not prove the network is healthy. In vanilla city Skylines, vehicles that sit trapped long enough can despawn after their internal weight counter reaches its limit. That can clear blocked vehicles from the road and make the traffic number look better than the system actually is. So the real question is whether the economy confirms the road result. If freight is failing, the symptoms usually show up somewhere in the supply chain. Commercial zones can trigger not enough goods, industry can trigger not enough raw materials, and if deliveries are not completing, the city may look clean on the traffic overlay while the production chain is breaking underneath it. That is why I'm not only watching the traffic score. I'm checking whether goods, raw materials, and deliveries are still moving. The traffic number only counts if the supply chain still works. Okay, well, we've ran for a couple minutes now. We're definitely seeing a little bit of a not enough worker problem, and we're seeing definitely crime. That's kind of normal and expected from this kind of crazy fast slam down growth of a district we just put down. What we're really interested in is the fact that we're still sitting at 86% traffic. Now we are seeing definitely more usage on the roads. Our heat map is definitely getting hotter, but not where we thought or might expect it to, which would have been pushing out of the industrial. We're seeing an influx in traffic with the trash complex. We're seeing an influx, which is expected with the sheer growth and volume of residents we have here. We can go ahead and kind of put a district around this real quick and see what kind of population we do have sitting in this one hub. And so we have pushing 5,200 residents just in this one additional test block we threw down. So we definitely have heavy commute, and we should be having severe traffic issues, or at least throughput issues that should be blocking our roadways for our freight to come in and out and to supply these and commuters and everything that you would expect out of this kind of growth. But we're still functioning at a pretty high rate here. Still sitting at 86, and we're still seeing normal traffic flow on our main collector. So I think we're kind of at the point now, there's not a whole lot more we can test, because realistically, Ridgewater's not going to grow this way, for one, but it also tells us that while we might have moved for realism, we're still holding up on a game mechanics side, and our main road network is still performing at a high level. And I think that's really all we need to see. This was never a realistic build pattern. It was a pressure test. The question was not whether Ridgewater should grow like this. The question was whether the road network underneath Ridgewater could handle more pressure before I start building on top of it again. And the answer is yes. Traffic reacted, the collector heated up, the test node showed stress, but the system did not collapse. Freight kept moving, the supply chain stayed intact, and the road network held without lane connectors, signal timing, a turn lane fix, or new highway access. That matters for Ridgewater, because the next step is not rebuilding the road system. The next step is trusting it enough to keep developing around it. So I think that kind of wraps us up for today. I hope you guys enjoyed this episode of Enter the Sandbox, and if you have any ideas or any comments, anything that I missed, I'd love to hear it. Any ideas for future episodes, I'd love to hear about. And if not, I hope you enjoyed this episode, and we'll see you next time when we dive deep into problems or successes or anything that kind of breaks down game mechanics versus realism and optimization and the technical side of building cities under the restricted game mechanics that do exist.